sound. You don't need sound.
We all were like, well, I mean, I guess like.
Like, why are we doing this time?
Like, wow.
Oh my gosh, hi Lisa!
Get over here.
Lisa!
Here, let me grab another chair.
Should we go get a stool?
Yeah, probably the tall one because she's short.
Which
I'll
one's
grab
the
that
tall
one.
one?
The white one.
Oh, okay.
Actually, I need to take up
Oh, wow.
fewer. It's heavy.
Ooh.
I feel like if I make sounds, it
Thank
feels
you.
not as heavy.
And Bruce, are you sticking around with us?
Yeah, sure.
Okay.
All right,
Hope I didn't break
cool.
that.
All right, we're all just gonna hang out now.
Awesome.
Because there was definitely questions in the chat room that did not exactly get answered.
Yeah, that's awesome. So, but I just want to give a little shout out to NASA, who's been working with us up at Griffith Observatory a lot. We're going to be collaborating on a live stream for Mars Closest Approach on Monday night into Tuesday morning. So tune in, 10 p.m. Pacific Daylight Time. Monday to 2 a.m. Pacific Daylight Time Tuesday. Figure out what time that is wherever you are, because Mars Closest Approach is happening at 12:35 a.m. Pacific Daylight Time here in Los Angeles. Mars will be directly overhead when that occurs.
man.
That's awesome.
So,
I'm so committed
that
to
means
Griffith.
that for those of us in California and on this area right here, we're actually going to be the closest people to Mars.
That's really exciting.
So, which I'm so excited about.
Are you guys just doing a live stream, or are you having people come to Griffith?
So
Can I just show up?
we will be open to the public. The
That's a
outside,
terrible idea.
The interior of the building will not be. I'll just throw this out there to you, which is in 2003, the last time there was the Closest Approach. We had an event. 18,000 people descended upon the observatory.
So if you want to go, you
What?
should go now and just
Yes.
camp out.
And
for it?
Basically.
Okay.
Basically. So
Is like the entire hill just filled with people?
not just the entire hill, the entire neighborhood around.
Oh, I bet your neighbors love you for that.
The freeways within a mile and a half
Oh
stopped.
man.
So that's how
Wow.
big it was. So if you're, I would just watch it from home.
No, for
Honestly, so. I will be.
Monday night
I'm
to
working
Tuesday,
the stream,
Griffith
but I'm not going to be on
yeah.
it as far as I
Mars
know.
Closest
I'm going to be
Approach.
behind a camera working it. So
That's a shame.
But I will try to make as many jokes as I can to make my bosses laugh. So,
Good.
It's gonna be good.
but yeah, I'm really excited about it.
Oh,
Nice.
man. I still want to go though.
So, Mike, Athena, Lisa, did anybody have any questions for our guests that you guys didn't get a chance to? I mean, because Jared was the one asking all the questions.
Right. There was a lot of good questions that were pretty much answered.
What were you working on before the Insight lander?
Well, I was working on trying to get the Insight lander selected by NASA. That's been kind of my sort of number one job for like 25 years. But to pay the bills, of course, I got to actually do something for other people. So I was the project scientist on the Mars exploration rovers for about 7 years, Spirit and Opportunity. I wasn't on the mission during launch and landing. I came on about a year and a half after it landed, and the project scientist for MER moved on to MSL, and I kind of, all the dominoes kind of went, and I kind of moved into that position. So I was project scientist on MER for a while, and before that I worked on Mars Global Surveyor. Oh man, that was a long time. It's from
Wow.
about 88 all the way through when it went dark in 2002. Worked on the laser altimeter experiment on MGS and Mars Observer before that.
Wow.
So
Wow.
So you're very well.
yeah, and I got to play with Magellan for a while too.
Oh, cool.
Oh, wow.
Radar mapping at Venus. That is so cool. So you're
Yeah, Venus is
The
definitely
Insight
my
lander-
second most favorite planet.
so you kind of have a close personal relationship with Mars.
Yeah, yeah. It's we all have our favorite children. We don't usually talk about it.
It's good. It's really good.
Oh, there's
Since the Insight lander shares a lot of similarities to the Phoenix lander, how closely did you work with the people on that team? And were you involved with the Phoenix lander at the time of its mission?
I actually wasn't involved in Phoenix at all. It was completely independent. My scientific interest, which kind of fuels all this, is in the deep interiors of planets and their sort of long-term history and evolution. And Phoenix was very very tightly focused on the question of water ice at the poles and that sort of thing. So I really wasn't involved in that. Of course, being at JPL, you get to, you eat lunch at the table next to the people who are talking about, this issue or that problem and stuff. So you get a lot of kind of inside information, but and you're cheering them along. But I didn't work on Phoenix at all, which is kind of ironic since now I basically have a Phoenix spacecraft. But I tease the Phoenix people and say, that I'm really glad that they did a thorough checkout of my spacecraft, but now we'll do something really important with it.
Thanks for doing a demonstration mission for me.
Yeah, that's right.
This is a pretty funny question from the chat. I see from Kim McCoy. He says, "Is the team going to be living on Martian days for some part of the mission? Do you guys actually sync up your schedule with?" Yeah.
Actually, we're not. Like, this is going to be I think it's the first Mars landing mission that's not going to do that, and the reason is money, because if you're on Mars time, that means you have to be able to operate this. You're operating the spacecraft around the clock, which means you have to have an extra shift or two of people on the payroll, so that people can sleep, because it turns out that nobody can actually sync up on Mars time indefinitely. After a while, you just go insane and start doing crazy things and seeing, purple cows, floating across your computer screen.
that doesn't happen regularly.
Without drugs. And so, in order to keep our costs down, we decided to go on what we call modified Earth time, which means that we have 8 to 10 hour shifts that can start as early as 6 a.m. and can go as late as 11 p.m. And so it can kind of walk through the day, sort of following Mars time for a while. And then when we get to where it's late enough to where our uplink is too late, or our downlink comes down too late, we basically just pop back to a normal shift and skip every other day, because we don't get the information down from the spacecraft early enough to be able to put together a command load before it has to go back up to the spacecraft in the day. And so we go for about 3 weeks, 2.5 weeks, kind of walking through the day, and then we spend about a week kind of going every other day, and then we have to reset our alarm clocks and get in at 6 o'clock in the morning again and kind of walk through the day again. So that ends up saving us millions of dollars. It turns out it's kind of crazy. But so we don't get the cool Mars watches, Mickey Mouse with the 24 hours and 36 minutes on it. But
wait, that sounds awesome.
Just have to go on eBay and pretend,
I think there was, if I remember correctly, like an actual set of Mars watches made for JPL, if I recall correctly.
Do you have one?
Absolutely. I don't have one, but I'm probably going to get one just to, like I said, so I can pretend like I was on Mars time. And honestly, I probably will end up being on Mars time for the first month or two. It's hard to resist, going and see what's happening all the time.
That's kind of cool. I'm sort of tempted to do like a Mars time challenge, 21-day challenge.
Yeah.
Go on Mars time.
I would
Create like a Mars calendar.
And see if you can touch your nose at the end. Yeah.
Between the purple cows and the Mickey Mouse watch dodging.
Goes in,
That'd be a really good
backwards.
psyche challenge.
So,
Oh man, I would volunteer to do that for NASA. Like get some data collected and estimate how many people can survive to be Martians and adjust accordingly to the time. But yeah, that's interesting because there is a lot of like psychological suffering from that. What did you say? Have you actually experienced much of that, or putting all aside the joking?
I don't understand what you mean.
As far as, I know you were joking saying that seeing purple cows and everything, but have you actually experienced like some really crazy situations where going on Mars days, you'll feel really off?
No, I wasn't on a Mars surface project when it was on Mars time, so I've heard stories.
Oh, okay.
Although I did I drove across the country a couple of times, and by the end I was seeing some weird things, without sleep. I mean, yeah, circadian rhythms are a really interesting subject of research, actually, but you should do it with a professional.
We should ask the standard questions. I would ask them. I don't have a microphone on, so.
Oh yeah, we didn't.
yeah.
Unfortunately, we didn't get to ask the standard questions like we usually do. It's a set of questions that we ask every guest. There's no right or wrong answers to it.
You can grab the mic.
So
It's like truth or dare kind of thing.
it's not like truth or dare. It's just more like do you want to just go into the questions and you can find out? So
Yeah, let's just go into. This is just it's just more like
that.
it's almost like a poll of what we ask all of our guests.
actually, Mike, do you want to do it? You want to?
Yeah, one virtual guest to another, sure.
It's the holograms.
The holograms will talk to each other. So.
There you go. I like it.
God, they might-
Oh, he's gonna look at it too. I love it.
Exactly.
So good. That's so good.
So, you guys might have to help me out with this a little bit, but what is your favorite space mission, past, present, or future?
Favorite space mission? I
Can
would
be
have
anything,
to
no
say,
wrong answer.
I'd have to say Viking. Viking's my favorite space mission because I was actually at JPL as a student when Viking landed on Mars, and that was just even more to me more than Apollo. Viking was like the first spacecraft sat down on a planet, and that first image kind of came down kind of line by line by line, and you're sitting there seeing the rocks on Mars. I mean, you can kind of look up in the sky and you can almost see the rocks on the moon, and the moon's cool, but Mars was just another world, another whole planet that was just so incredible. And so, the fact that we'd actually sent something and a robot that landed all by itself on another planet. I mean, so Viking is I think my sentimental favorite.
Well, this might be a biased question to ask you, but do you think that we should explore the cosmos with humans, robots, or both?
Both, definitely. I think that the only really deep, pure exploration has to be done with humans, and spending 7 years, with a robotic, couple of robotic rovers on Mars, Spirit and Opportunity. It's so time-consuming and tedious to get anything done remotely on a planet with a robot. It's super cheap compared to sending humans. It's much safer, and you can do things that you might not want a human to do, like crawl down in a volcano or something like that. And so I think robots are definitely the first wave that you should send for exploration, and but without humans, you're never really going to get deeply into anything. I mean, a human can figure out, in 1 hour, a human can figure out stuff that would take a year for a robot to do. So it just doesn't make sense to do it without humans. But I'm definitely a big fan of robotic exploration. Don't get me wrong.
That seems to be a general consensus too, which is pretty cool. So.
Yeah.
Where do you think that we should explore next?
Well, I think that we should. I was listening to the discussion earlier about Mars versus Enceladus and Europa, and I think that again it's kind of an all of the above situation. Mars has a lot to tell us about the Earth, about the evolution of the inner solar system, and I think especially we have such a great data set on Mars that and we're kind of being able to get into deeper and deeper scientific questions. So I think it'd be a big mistake to kind of shut down Mars exploration. But meanwhile, Venus is almost pristine as far as exploration is concerned. There's and here we have the twin, sort of Earth's evil twin, that it's the same size and the same mass as the Earth, and yet the surface environment is so different, and the geological evolution has been so different. If you start looking into details at the surface of Venus, and so I think Venus is someplace that we really need to start figuring out how we can get down and start doing some in situ exploration. Europa and Enceladus have so many mysterious things going on, and there's the tantalizing possibility of some kind of strange life living in the deep ocean beneath the icy surface. That's definitely someplace that humans should set their sights on exploring, and and on and on and on. I mean, the thing about exploration is there's you never reach the horizon. There's always someplace to go. But that's kind of my personal priority, which is colored by my scientific interests and what I've been studying and curious about. It's kind of Mars, Venus, and Europa/Enceladus.
Awesome. Let's see. Did I forget any of the standard questions?
Why space?
Why space? The most important question we ask.
Yeah, kind of, but that's cool.
There's actually a politician, and I won't name him/her, but ask a colleague of mine once that says, "What's the purpose of the planets?" And he was just kind of, "What's the purpose of the planets?" And so, okay, well, so why space? I mean, space is how you get to where you need to go. I mean, space is part of the universe around us, and that's like asking somebody that grew up in Maricopa, California, why go to LA, or why go to New York, or why go to France, or why leave your backyard? I mean, you leave your backyard to learn new things about the universe you live in, and space is just kind of a logical extension of that.
Nice.
That was such a cool answer.
Awesome. Very
Yeah,
cool.
no, that was
Yeah.
really good.
Cool, yeah.
That's well said.
And I didn't grow up in Maricopa, by the way. I mean, I grew up in Taft, which is much bigger.
Yeah, I was going to say, you have something against Maricopa. No, I'm just kidding.
Oh, that's good.
No. One question that I did have that isn't part of the standard questions is, as far as I know, there are pockets of magnetic fields that do pop out occasionally from the surface of Mars. Is InSight Lander going to be help to understanding what that is and understanding, whether or not those are magnetic effects from some sort of ore, or if that's coming actually from the core itself? Or is that even true? Am I
contribute to that. I'm not actually an expert on magnetic fields, but we are actually landing kind of right on the edge of one of those what we call magnetic anomalies. One of the magnetic highs is just kind of off to the side of the InSight landing site. And so we have people on our team who are interested in those magnetic anomalies, which appear to be generated within the crust from ore bodies, as you said. We definitely will be looking at the magnetic fields from the core, which have not unambiguously been detected. I mean, the magnetic fields that we've seen at Mars so far seem all to be from either just magnetized crust, which are just rocks that have a magnetic field frozen into them, or from currents in the ionosphere. And so one of the nice things about InSight is it's going to be stationary. So both the other magnetometers that have gone to Mars have been on orbiters, and so you have the motion of the orbiter that gets sort of convolved with any variations in the magnetic field, and so we'll be able to look at the magnetic field from just a little bit different sort of dimensional space than orbiters do. At the same time that the magnetometer on MAVEN will be looking at it from space, and so actually having two magnetometers looking at at different scales is going to be extremely valuable in terms of being able to unravel the sort of the dynamic versus the static magnetic field of Mars.
Yeah,
Wow.
definitely.
That's so
You know,
awesome.
those two sources. That's great.
We have a
Yeah, I've
question.
often wondered whether or not those magnetic anomalies are strong enough for like any sort of habitats or anything like that. But anyway, that's
Yeah.
Oh, that's a really interesting theory. We had a question from the chat room. So who am I going to go with this one? Mike Kayansik on YouTube asks, how will InSight handle planetary-wide dust storms? Kind of like the one that Opportunity is going through at the moment.
That's a really good question, and we thought about that a lot and worked on that a lot because the Phoenix spacecraft wasn't originally designed to worry about stuff like that. It was going to the polar region, and it was only supposed to last for 45 or 60 days or something. So we've taken the Phoenix spacecraft, and we need to use it as a long-lived lander. We want to last at least 2 years, 1 Mars year on the surface, and so we knew we had to deal with dust storms. So we did a couple of different things. First of all, in terms of landing on Mars, we knew we were going to be landing during dust storm season, and so we looked at the effects of of dust on sandblasting the heat shield, and they did some experiments and some calculations, and based on that, we added about a half-inch more ablative material to our heat shield than Phoenix had, and that should take care of the maximum amount of dust we might see in the atmosphere in terms of landing. Once we get on the surface, the problem with dust storms, of course, is they block out the sun, and when you block out the sun, your solar panels don't work as well. So we made our solar panels a little bit larger, about 6 inches in radius on each panel, which increased their output by about 15% or so, 15 or 20%. Which helps, and the solar panels at the equator actually generate a lot more electricity than we need in kind of a normal situation, which gives us a lot of margin if the insulation goes down because of dust obscuration. And we actually also made put a special set of circuits in the spacecraft that we call the dead bus recovery system. And what that means is that if we get into a dust storm, which really blocks the sun for a long period of time, and our batteries just get completely depleted and get down below the voltage that can actually operate our electronics, everything shuts down, and the spacecraft basically goes into a coma. But we built it so that there's the power system is actually just open all the time. So when the sun comes back on the panels and starts pumping electrons through the system again, the power system will kind of self-boot itself and then start charging the batteries. And when the batteries get up, they'll reboot the spacecraft computer, and we're off to the races again. And so all we have to do is worry about how cold it gets in the meantime, because sometimes the really intense cold on Mars could cause failures in the electronics. So we always have a danger when that happens. But we actually designed the spacecraft with enough margin to survive any dust storm that had been seen on Mars up until our design point, which was the one that actually ended up killing Spirit, I guess. But turns out this storm is, of course, more intense than that one, and would have probably put us into the dead bus state. But by the time we get there, this dust storm should be pretty much dissipated. So we can survive most dust storms, but there's every 25 or 50 years there's one that's gonna knock us out for a while. But even then, we have a chance of recovering if we get lucky.
That's so cool.
I'm really confused right now.
What you're doing is you're looking at our guest through the camera, but what's happening is that literally everybody else watching is getting freaked out because you're staring them down. As opposed to looking at the guest naturally on the TV.
I'll step in. So
then Ben gets behind the camera.
Which you couldn't see is off camera. I walked in and I stood right by the screen and I just started
And she immediately
staring.
stops. She looks down really quickly.
Staring at Lisa intently, and she's like, "Oh God, I don't know what I'm doing wrong, but I'm not gonna look at Ben."
Oh man.
To be fair, I did not sleep very well last night. So.
This is true. And also, to be fair, Bruce, what you were saying was highly interesting. So I can totally see where you were captivated.
Yeah,
In my
especially with
in my head, I'm visualizing
Everything.
InSight with all these extra
Yeah.
dust precautions?
So this storm, the current storm is like one of those 25 to 50 year storms. It's just like, it's
That's right.
absurd. And if I remember right, this is the strongest,
Wait, that's
basically
really
the strongest, or the opacity of the atmosphere is, this is the like, what is it? I think it's measured in something called tau, if I remember correctly.
That's right.
And this is, they basically from Opportunity got the highest reading they've ever got from the surface of Mars, and then Opportunity turned off. So
Right.
yeah.
Yeah, the highest tau before was about 4.5 that they measured about 4 or 5 years ago. And normally tau is around 0.5 or maybe 1 on a kind of a hazy day. And 4.5 is pretty dim. And I think Opportunity measured something higher than 8 before it went offline. So this one is a really strong storm. And by strong storm, we don't mean like, the Martian where, things are blowing around and spacecraft are tipping
That
over and
doesn't
stuff like
happen.
that. Because, it's that's not the way it works. But what we measure storms in is how much dust gets lifted up into the atmosphere. And if you're actually on the planet, you might feel a gentle breeze, but that's about as violent as it gets.
Oh, wait, really? You would just feel
Really?
a
Yeah.
breeze. Wow, because
Yeah,
I was
this
thinking what it's going to be like for
even
humans.
like 100 meters per 100 kilometer per hour wind on Mars would feel like about a 8 or 10 mile an hour wind on the Earth because of the atmospheric density difference.
Oh, wow. Oh, I didn't know about that. That's really cool. So then when it comes to considerations for the construction of Martian cities or whatever it is we're really going to be building there for humans to really be encapsulated in. That's interesting because I was thinking, oh my gosh, this is going to have to be super stable. It's probably going to have to be like at least 50 floors deep, and the basement's all going to be really, really deep. And but that's interesting that it's going to be that light. I actually didn't realize that. I guess that's why also the rovers are...
Until we terraform it, of course.
Until we terraform it. Yeah.
Hey, I wanted to ask you
good.
about the cameras on InSight. You said that there's context cameras to help you figure out where to put the seismometer, the seismometer and the heat flow probe. Are those the only cameras on board, or have you got other cameras?
No, we have 2 cameras on board. One is, and they're both actually spare cameras from Curiosity. One's what we call the nav cam, which is the wide angle, 120 degree field of view that gives kind of a distorted picture, but you can see, all around. And we have that hard mounted below the deck that shows basically the entire area that the arm can reach, all in one frame. And so that's a really good guide for us to figuring out, where to put our instruments. And then the other camera is a nav cam. So we've got the HAZ cam below. We got the nav cam. It's actually attached to the robot arm. And so instead of having a separate mast with motors and things to point it, we actually just attach it to the robot arm, and we just point to what we want to look at with the arm.
That's cool.
And then we can take a picture. And so it's a little bit higher resolution and a narrower field of view to take a little bit more well-defined pictures of spots, and we can put together mosaic of that'll show our thing. The difference with Curiosity is we actually took them apart and put a color filter on over the detector. So instead of having black and white, we actually have full color pictures of with our nav cam and HAZ cam. So that'll be cool too.
That's gonna be sweet.
Yeah.
So are you guys gonna literally like move the robotic arm around in order to just take panoramas and stuff? So
yeah,
cool.
At one point, we're just going to take a full 360-degree panorama in stereo and color.
In 4K?
And it'll probably take months to download it, but it'll be awesome.
Are you guys also planning on taking pictures of the materials that the lander's made out of to see how it's holding up on the surface of Mars?
Yeah, we'll take deck pictures as well. In fact, we have our calibration target is over on one side of the deck, and so we'll be taking sort of regular pictures of that and be able to look at dust accumulation and any kind of either erosion from windblown dust or degradation from ultraviolet or cosmic radiation, stuff like that.
Nice. One thing I did forget to talk about during the interview, which I thought was really cool, is that you guys have several microchips on board of InSight that has people's names, right?
That's right. We have 2 of them because we have one that we put together during the 2016, launch campaign. And then when we didn't launch, we said, well, we might as well open it up again for another one. And so we got, I think we ended up with like 2.3 million names between the two chips.
Sweet.
And they're glued onto the deck right next to our calibration target. So we're going to take pictures of people's names every few weeks on Mars as well.
Wow, that's so
That's
cool.
really cool.
Yeah, my name's
name.
on the 2016 one, I think, and I got my little passport to Mars too, which we just had a photo of some folks there with theirs in front of Insight.
That's actually me on the right, and my
there you
project
go.
manager Tom
Wow.
Hoffman on the left with our boarding passes to go to
Oh,
Mars.
I love it.
So when you submit your name, you get a boarding pass. And so
Yeah, I
you
think
can
I got
Excellent.
one of those too, actually.
accumulate frequent flyer miles. All the Mars missions have.
I think
Oh
you
my
need
god,
one
I
of
would get
those.
platinum status if I went to Mars.
Yep.
You need one of those by 2020 to fly, right?
VFR flight.
Anyways,
We'll definitely need one of those passports.
That's amazing.
Wow. That's really, really cool. Pictures. What about selfies?
I have another question. After you get a bunch of data back from Insight, what is your next objective? What's next for you? Are you planning another type of mission to Mars? Is there other questions that you want to ask that this mission isn't hopefully going to be answering? And is there a possibility of another slew of possibilities depending on what this mission's results are?
Well, I'm not sure I have another 25 years to get another mission going off the drawing board. But eventually, what we would like to do from a geophysical standpoint, from an interior standpoint, is have multiple stations on the planet. So I would love to send a seismometer with every mission that goes down to the surface, because there's things you can do with seismology with multiple stations that you just can't do with one. I mean, we can get sort of a reconnaissance of the planet, get the sort of the major divisions of the interior, but to really start asking some of the detailed questions about the origin of Mars volcanism, how the depth at which the magmas are generated, things like that. You really start needing to get multiple stations, and I'd love to advocate for getting some more seismometers on Mars. Past that, I would love to see a mission go back to Venus and start answering some of our questions about the age of some of those surface features, the composition of the interior, whether the mantle of Venus is dry or whether it has a lot of water that's dissolved in it. That's kind of a basic question that goes into whether plate tectonics could ever occur on Venus, and whether the atmosphere could ever turn into something that was not some kind of a hellish greenhouse and could actually support a life as we understand it. So I think a Venus exploration mission is really long overdue. And meanwhile, I'm just watching these missions to OSIRIS-REx is going to be bringing back a sample of an asteroid pretty soon. We've got a Psyche mission going to a fragment of a planetary core. I mean, there's lots of missions already that are either being built or operating that are going to be super fascinating. So I'm just sitting back and it's just as a planetary scientist, sometimes I feel like a kid in a candy store. I mean, we're really in the middle of the golden age of planetary exploration right now.
We really are. Yeah.
Regarding Venus, what do you think about the ideas of the floating colonies in the upper atmosphere of Venus? Do you think that's a viable thing?
I have no idea. Sounds cool. I'd say people have a habit of solving those kinds of problems if they really set their minds to it. I mean, that's one thing I've really learned working with the engineering team, at JPL and Lockheed Martin and our instrument partners is every week we come up with some problem and I'm going, oh my God, that's a showstopper. I don't see how we can possibly get by that. And then there's some guy or some girl somewhere who's like, oh, I know how we can fix that. You just do this and this and this and this, and I'm going, oh my God, that's perfect. And so human ingenuity is just incredibly deep. I mean, so yeah, floating colonies on Venus, why not?
That's
That's
awesome.
awesome.
Yeah, JPL,
Thank you.
JPL seems like it's got the right people in the right environment to do those right things, and that's amazing.
Yeah.
So,
It is.
Totally.
It's an amazing place to work, and I've worked there for over 40 years now, and I had no idea that it was as good as it is until I was in charge of this mission, and like I said, trying to solve some of these problems. And there's always somebody somewhere who was an expert on the thing we needed to know about, and they go, "Oh yeah, you just do this." And I'm going, "Whoa." That's just having world experts at basically any kind of a subject that you can think of is just amazing.
Beautiful. Well, Bruce, it was really amazing having you on, and maybe a little bit in the future once Insight is going, or Insight is going. What am I trying to say?
Has
here?
landed.
landed
Thank
and
you.
done some science.
That's what I wanted. If you wouldn't mind maybe coming back and then giving us some updates and thoughts, feelings, experiences of how that all went for you. I think that would be really cool. If you don't, assuming you had a nice
that'd be
time
fun,
here.
yeah.
All right, cool.
We'll
Very
definitely
cool.
have to set that up.
Yeah, awesome. Perfect.
Wonderful.
Well, that's about us. It for us this week. We have a lot of work we need to get done. We have an entire green room that we have to get ready for Mr. Peter Beck is coming in town, and so we got some stuff we got to clean up. So again, thank you to Bruce, Jared, great interview. Mike, Athena, Lisa, thank you for hanging out. Everybody here in studio, of course, and to all of you, thank you for joining us. We will see you guys next week. Have a good one.
See you
Goodbye.
next week.
Bye.